Hey everyone, and welcome back to HSC Maths Tutoring with Nathan. And today I'm going to show you how to do trig proofs. And I'm going to start with this 3-unit compound angle proof. I'm going to show you the process I used that will work, that I've created, that will work for basically 95% of trig proofs. So we're going to prove this massive formula equals 0. So obviously, with trig proofs, the first step is pick a side. Now the obvious side here would be the left side because the right hand side is 0. You're not turning 0 into the left hand side. It's near impossible. But what I like to do, or what I create, is I call this the manipulation list. So by using this list, this is expanding, factorizing, adding and subtracting fractions, and this is sub-identities. Oh, it's horrible. So basically, this is a list I get to pick from. So when I do left-hand side equals, I just go through this list and find the first thing I can do or the best thing I can do, right? At some stage you might be able to do multiple here, but you want to pick the best one. Now if we look here, so you basically go through the list. Can you expand? Well, no, because these aren't timesing. These, you should know about this is not signed time, so we're not expanding. Can we factorize? Well, no, nothing's common for all of it. Add or subtract fractions. Well, yeah, we could technically add or subtract fractions, and then sub-identities. Well, yeah, we can sub the compound identities for the numerators. So the best thing here is actually to sub the identities, right? Adding and subtracting the fractions won't actually help us at the moment. So the best thing to do is to sub the compound formula for sine in. Cos A. So remember, sine, it's sine A cos B minus cos A sine B over sine A sine B plus sine B cos C minus cos B sine C over sine B sine C plus sine C cos A minus cos C sine A all over sine A sine C. So we expand first. Now we could go back to the step where if we go to this list we could add or subtract the fraction. But in doing so, it's not going to look really pretty, really, because there's going to be a huge number of terms. So the reason I picked this example is I just wanted to show you the one case where this list actually doesn't help you exactly, but because there's a trick here. I wanted to show you a special trick. Right, so this list will help you do 95% of trig proofs. This one falls in the 5% that it doesn't. Now if you want me to go in a future video to show you this list properly with a couple examples, just comment below, but I now want to show you a special trick here. What you'll notice here, if you look at the numerator here, I've got a sine A and a sine A there, and I would like those to cross out because they would simplify my working. But I've got a minus here, which means they can't simplify. But then look here, I've got a sine B and a sine B here, which would cross out. So this is a very simple trick, very powerful, but whenever you have one term on the denominator and you notice stuff can cancel out, what we can do is we can actually split this into two fractions, which I'll do down here. So the left-hand side will now be sine A cos B over sine A sine B minus cos A sine B over sine A sine B. And we can do that for the other two fractions. So we just scroll up a sec here. So then this will be plus sine B cos C over sine B sine C minus cos B sine C over sine B sine C plus sine C cos A, sine A sine C minus cos C sine A over sine A sine C. Here's my favorite bit. I get to go through and cross out all the like terms on top and bottom now. They're gone over here. Sine B's, sine C's, sine C, and sine A. And what you'll notice now, in doing so, we can go through this list to help you again, but what you'll notice at this stage, every fraction has cos over sine with the same letter, which means we can use our identity. So we're going to go to S here. What's cos over sine? Well, that's cot. So that first one, cos B over sine B, is cot B minus, then there'll be cot A, plus the next one, cot C minus cot B plus cot A, and then minus cot C. And what you'll notice is they're gone, and they're gone, which is 0, which is the right hand side. So I picked this example to showcase this very simple yet effective trick of when you notice, so we go up here, when you notice the numerator and denominator have common terms, we can split the fraction into 2 terms to cross out those like terms. And in doing so, made this question very easy. If you followed the straight process going through this list, adding and subtracting the fractions, it would have become very messy, because basically you'd have to times this by sine C, these by sine A, and these by sine B, and try and add a like terms. You can have a go at that, but I don't think that would look as nice as this trick. So, right, this process, following this list, will get you the answer, but sometimes the special tricks like this one of splitting a fraction into 2 that make it much nicer and quicker. So if you enjoyed today's video, make sure to give us a like and subscribe for future videos, and comment below what you'd like to see in future videos. Otherwise, I'll see you guys next time.